Okay, so in this video, we're going to talk about finding local extrema, and we're going to pick up right where we left off when with finding increasing and decreasing intervals, because they're very much related. So a local extrema means you either have a local min or local max, and we're going to see that again using our first derivative. We can see it right here from our first derivative number line. So if we know from here our graph was going down, it was decreasing, and then we know at negative 1.733 our graph started increasing, then we know we had a local min. And similarly here we know our graph was increasing going to decreasing, so we know we had a local max. And then here at the asymptote we went from positive to positive. It's an asymptote, so there's nothing there. So therefore for my for my local extrema, I'm going to go ahead and say I know the x value is negative 1.733 comma something, and then I know my y value. Let me get rid of that. My y value would be very similar, my y value would be there, and my other value would be 1.750 for my max, and I'm going to put the y value there. And how we can get those is using our graphing calculator again. So now here's the fun part though. Which y values do we want? Do we want the y value from our derivative, or do we want the y value from our original function? Well, we want it from the original function because we want the actual y value. We don't want the rate of change. We don't want the slope at those. We know what the slope is at those points, 0. So we're going to go ahead and turn our graph back on for our y1. So that way when I go to my table, now I'm going to type in negative 1.733, and out comes my y value. And then similarly so now I can fill in my y value of negative 0.0. I need more space. Here we go. All right, so now I can actually write my y value of negative 0.0096, and then the other y value of, the other x value of 1.750. The y value would be 0.0095. So there we go. So now we have, and we know that this one, because looking at our number line, we knew that this one was a local max and the other one was a local min. And I'll show you one other little way you can do this. If you're from your main Blinky screen, we can use vars, y-vars, our function, and we want our y1 function because that's where our original function was typed in. And if I want to evaluate it at a number, I just use function notation. So I can type in y1 and parenthesis and then type in my x value of negative 1.733, and then when I hit enter, notice it'll give me my same value there. So two ways doing the same thing, finding local min and max using our calculators.